Well, I got interrupted the first time around, but I'm going to try this again. Heavy duty connecting rods. I guess I have to keep things a little simpler sometimes. I got interrupted properly because they're having some other trouble with communication gaps in the medical community. Anyway, we're talking about connecting rods, large, heavy duty. The one that JAMSi Online, I think, was posting appeared to be one from an 855 series Cummins, which means it could be anything from an NTC right on up to the latest N14. Most likely, because of the stuff that they usually get, it was probably in the Big Cam 855 series, probably, what do they call that one? The NT88, the big bad before they got into the electronic Select and Select Plus versions. But it could have been from the Select or Select Plus because they go back into the late 80s. Now, one of the things that was somebody had a question on there about why isn't the end of the connecting rod 90 degrees, the sides of the small pin boss 90 degrees to the pin. It's tapered. Aha. Let's talk about that for a short time. Because they showed them putting it in there, actually heating the rod up and sliding the bushing in. Why? Well, there's a special press tool for it. But heating it up and dropping that bushing in there, if you can get it in there tight, premium. That's probably the best way to go. Why? Well, the main reason is the jig. You have to hold the rod here. The jig has to have a taper to it. Push and start the bushing that has a taper in it, and it needs a guide. And let me tell you, I've done it without before, and it ain't pretty at all. Why? Well, you push the big end of the bushing in first, and then the little end, there's nothing to hold the bushing where it belongs as you put it in. You usually end up crushing half of them. So it's a mess. But why do they do that? Because it does have those problems. Well, main reasons is, number one, the piston is much heavier crown than the diesel. And the closer they get the crown of the piston to your wrist pin, the less movement that you have of the piston head over the rod. The higher up it is, there's a lot more differential movement. So it stays more in line. That's one. The piston's just plain heavier for the diesel loads when they're talking something that large. You know, you start talking 5-inch bores, 5 1/4, 5 3/8, 5 1/2. You know, these things with 6, 7, and 8-inch strokes. The closer you get that wrist pin to the head, the better your ring pack is, the tighter it is. So they put that up there, big old strong head of the piston, taper this thing down, and there's enough aluminum, especially around the pin bosses in the piston. That's the main thing as well. The second main thing as well is now the pin bosses and the piston are wider because the rod's narrower. Top of the piston's thicker, so there's place for the heat transfer to go. And as well as the piston cap is thicker, an oil squirter jet can send oil up through that cavity in the piston, and the oil can stay there long enough to cool something. Now, it doesn't always happen that way. Usually it's just spray some oil around the piston crown and back out. But still, they can pull those stunts off a little easier when they have more room up there to do it in a thicker piston. But that gets us into that part. The other one is your pin bosses and the piston are now angled this way as well. They're thicker here at the top when the piston pushes down. The rod itself is wider here where it needs to be, so the piston can be lighter down below itself and still have sufficient bearing surface area for what? For pulling the piston down. And the top of the rod's narrower to pull the piston down because it doesn't have thousands, maybe tens of thousands of pounds of force on it from combustion, let alone thousands of pounds from compression, just so they can get enough heat to fire. So that's that end of it. Those are the main reasons. The other one is occasionally, and it's usually for naturally aspirated engines that don't have turbos and such, you'll find those engines will have a drilled rod on it. And the drilled rod will get up in there and start pushing oil around, and it can splash on the backside of the piston rather than having oil squirter jets on it. But usually if they need oil on the piston, they're going to use an oil squirter on those big engines. They build them with it for the turbos. Majority of the engines are turbo. You're going to have oil squirters there. Just fact of life. But that's one of the others. Another reason to narrow it up there is if you're talking a rod that's not a drilled rod, which majority of your 855s, all the 855s are going to be because they're almost 100% turbocharged. They'll have a drilled port it's forged in there, but there'll be a drilled port all the way up into the wrist pin. So if they don't have the drilled port, then that taper in there allows oil to come in, and as it rounds the wrist pin from the narrow part, okay, your wrist pin's coming in out here, splashes, lands on the wrist pin, and then follows that taper down and lubricates the wrist pin as it turns. So, and that's a minor, most of it is just plain rod stress. That's what it adds up to. Stronger piston head and a tougher rod down here when the piston pin hits it. So that's the majority of it, period. It doesn't have much, because it's a pain in the butt to do it. They have to machine it at an angle. They got to bore, it's just, yeah, there's a reason it's more. Do you want your engine to go 500,000 miles without being torn down? That's one of the reasons. Solid stability. Now, as long as you have a wrist pin that's rugged enough, and on these puppies, they're monstrosities, then your pin doesn't flex. You've got a very, very strong unit. So, which some of you purists might also know, is now that it's tapered, all right, now you got your piston over the top of it, and when it pushes down, yes, the widest point of the piston is directly over top of the wrist pin, which is directly over top of the edge or slightly inside the edge of the connecting rod, meaning there is no, it cuts down the wrist pin flex immensely. So there you go. It puts some of the stresses directly in line from the piston to the rod. So that takes care of the top end for the most part. Now you'll see wrist pin bushings and other ideas of how oil sprays in the back of the piston. Now some of the rods aren't drilled, and you can go through 1,000 other things, but those are the main things of it. So the bottom end, however, let's go to the bottom end. Now that rod for an 855 is a very, very long rod. One of the partial weaknesses, but also one of the best parts of that engine. The block was very tall and the rod was very long. Why did they do that? Well, back then they knew and didn't have the metallurgy, et cetera, we did later on. And the long rod, yes, even though it's more susceptible to bending just because it's long, they make it heavy enough to handle the stress, but the long rod means the geometry between the wrist pin and the piston stays closer. And if it's shorter, they bring it way up here. Now your angle is much steeper. Your wrist pin was down here. Now you shorten it. Your crank pin is still here on the same stroke. Shorten the rod to piston. And you've got a lot more wall force, both on the major force and the minor force walls. What's the major? The major force is when power hits it. It's rod's at an angle, it's going down, but it pushes against the side over here because it's trying to push that crankshaft around. Piston wants to go straight down, but the force of the rod's an angle. That's your major side. When it comes around, coming back up, now it pushes to the minor side. Well, the steeper angle pushes harder. Longer rod, higher distance between the wrist pin and the crank pin, is less friction. So that's why they built it that way back when, hoping it would last longer. So what did they do there? They needed a big crank pin. And you'll see that it's just a plain straight rodded bolt. Directly, the bolts are in line with the main beam of the rod. Later on farm tractors and some of the others, all of a sudden you see the rod cap on the bottom, the big end. You'll notice that it's seamed sideways. Why? Well, when you pull this way, you're full width. When you turn it sideways, you can take the cap off, move the rod over, and send a much larger rod, big end, down through the engine to the crank pin. And that's why that's at an angle on that end. No other reason, really, because it makes it harder to get to the rod bolts. You can start one down here, but then you have to take the engine, turn it down and around to get to the other bolt to torque it. It's harder to, when you put the piston down through, it's going to hit the crank pin unless you're very careful. So there's a lot that goes with it. Now the straight on connecting rods, a lot of them have studs in them, and if you don't cap the studs, you're going to hit the crank. And I've torn engines apart that other people put together before, and they couldn't turn the crank over, tear it apart, and the huge nicks from the threads on the studs where they hit the connecting or the crank pin and burred it so badly that when they bolted it down, it jammed into the bearing material and wouldn't turn because it was 4 of them. And one or two of them, they were able to turn it and they peeled bearing material. It was ugly. You have to put some type of protection on those bolts. Even when you're going through an engine, or those studs, I should say. But even when you're taking it through without that, you still need something in there to protect the crankshaft, whether it's your hands or something else, as that thing comes through. Now, a lot of them you'll see with me that I'll put those things together. I won't even put a bearing in the cap. I might throw a rag in there, let the thing come down through. And then once it's there, you can turn the engine over, or if it's sideways, you can go to the other side of the engine, and now you can finish guiding it onto the crank pin. But when they're at an angle like that, now it starts getting a little tricky to put it together. But when it's laying on its side, you put it in there so it's easy to put together. It's open at an angle, you shove the piston through, and even if you have that crank pin up, you're going to ding that crank pin. There's no way around. You're never going to avoid it. Put the crank pin down and protect it so when it comes through, it might hit it from the lower side, but if you have a rag or something in there, you pull it through as far as you can. Then you turn the crank pin so you can get your hand in there, grab a hold of that rod, and then put the bearing in it and slide it the rest of the way on. Now you can turn the crank up, bring it up, put your cap and bolt. It's a little more complicated procedure, but both ways are difficult. Putting in a straight rod with two rod bolt studs in there, you got to bring it in so far, everything down, get it up and line it up, and you got to be sure that you pull that over. The curious part is usually the studs are so close to the inside bore of that rod, the big end, that when you put the rubber caps on, plastic caps or anything else, just go to slide it on there and it'll pinch. But it'll center everything. So normally you have to use plastic, the plastic caps that you end up purchasing that are thin enough that you can get it in there. Because I've used fuel hose before, unless you're on a big engine, it'll go, and that's it, because they're too close together. So then you're wrapping plastic or something around the crank pin and getting that puppy up on there. So there you go. Now they put it in an angle on the bottom. Does it help any other way? No, because if you're drilling a hole, that's one of the reasons. If you're going to bore a hole for the oil to the wrist pin, pressure lube, full pressure lube as they like to call it, they can't go any further and still get in there to be able to drill that all the way through. Much difficult, even if they're using an EDM. But an EDM machine, you're usually not going. It's electronic, what they call electronic discharge, where they actually shoot electricity in a particular pulses and such, and burn holes in an object quicker, easier, and more precise. So they're either that or what they call it, some type of electric discharge machine, and it's usually computer controlled. So I saw one, and I've seen them in operation. I've been around them and saw some of the holes from them. They're pretty cool. But normally something like this you're going to machine, because you're talking a nice long port that you're going to have to bore through. Now, the other thing on the caps, you'll see some of the rod caps have steps. Some of the rod mating surfaces have wavy, almost what we used to call on, what do they got? We used to call them Z-links on the tracks on a bulldozer and excavators and such. There'll be a Z-link that'll look like a Z brake in a track, so they'll lock itself together. And some of them we called the gator. It was just like splines. They'll do that in the connecting rod as well. Don't ding the splines. You'll see some mating surfaces. What do? They have a shoulder on the stud or the bolt to line the two up when you put them together. Still quite often, though, when they do that, you put them down till they're snug, tap the thing side to side to be sure the two caps hit each of the surfaces on both sides so that they line up with each other, and then finish torquing them down. Some guys tap the bolts in the caps, so if they're off still just a little bit, that they'll tend to vibrate themselves in when they're halfway through the torque, and then they'll finish torque it. So those are some of the things you look at there. Now the other one, if you have a fractured connecting rod, fractured cap, do not in any way damage any part of that connecting rod in any manner whatsoever, under any circumstances, for any reason, any mistake, anything. Throw it away. They do have a way to rebuild them that I've heard of, never seen, that they actually smooth off both faces. Because what's a fractured cap? They make the big circle. They take press metal, and this is even beyond casting, and they take balls of metal and chemicals and carbon and whatever else they want, throw it all in there, and then they put it under heavy pressure in a mold of what they want, and it'll come out similar to a casting. Only it's steel, it's not iron. And they'll press that puppy in there so it is so rigid that it's brittle. And what they actually do is put the cap in a vise, and they have a little cracker. Some of them smack it with a hammer or put pressure on it. Then they'll take that big end, turn it sideways, and they'll fracture it. And that's it. Pull it away. It makes its own fractured surface. You bolt it back together. You can't put it together this way or this way. And because it's a perfect match, now you bore your hole, and the entire rod, grain structure, and all are matched together. It's a more rigid rod. A lot touchier, too. Don't screw around with them. Most of those are going to have, I don't think you're going to have a pressed-in wrist pin. I believe anything I've worked with those with fractured rod have been in diesels, Cummins, and maybe a John Deere or two. And they're all full floating pins. So it makes a difference there. Anyway, that's the idea I wanted to get at to help work with some of you guys. We're coming up just over 16 minutes, so I didn't spend a lot of time and get into a lot of other things. Now, when you go through your forensic studies, remember that each of these, the overlap of the tapered top rod and the angle of the bottom, they all have an effect on your reading when you're tearing these things apart and doing a forensic study. Your bearings on the, what would you call them, the angle boss rod, your bearing load is in the same place, but the cap is on there different. So the only thing that some of the guys that love those rod is it's a larger bearing. The load is in here between the end and the wide side over here. Well, they try to get that wide side so when that rod's coming down, it pushes outward. So the actual wear surface they're hoping is still out here. That's the theoretical value of it. They all wear straight up and down. But there is a little bit more to the one. It's up to you. They say that a straight-on rod has more of a flex out here. Maybe. Because it's at an angle. When it pushes under the highest stress load, it matches. There's reasons that they do the things. It doesn't matter because depending on how they put the engines together, they're all successful when they get through testing. Is one better than the other? I'm sure each one has its own advantages. But if you want a big, heavy butt-end rod and a large crank pin, you have to go with the angle rod, especially if it's a shorter stroke block, short rod, which is quite common in engines, especially ISM and ISX, Cummins, QSX, QSM, all of those types. The block is shorter than they used to be in their older series engines like the 855s and such. And with the shorter block comes a problem of skirt stress on the piston with a shorter rod. They'll have almost the same stroke as some of the older engines. So you'll see that their RPMs are limited quite often to 2,000 or 2,100, whereas the old 855 had turned 2,500 and it didn't care. But the one guy did warn me because everything is so big and moving so far and so fast. He says, when you get to 2,800 RPM and you know for a fact it didn't exceed 2,800, you're going to tear it down and put bearings in it. And he says, I mean every bearing. You'll be tearing it apart, looking it through and be sure it's okay, but you're probably living. The instant that engine hits 2,900 RPM, throw it all away and start over. He meant everything has to be started over from scratch. The crank has to be checked for straightness. The block has to be checked for straightness. The block has to be checked for deck, counterbore, everything, 100%, all over again. No shortcuts. He says they are that critical. Now, this is back in the big cam era, the NT88 series, or maybe even before that, because I'm talking 77, 78 in that era. So anything after that's the same basic design engine. Don't go over 2,500 RPM. And you'll find out that most of them were set up to about 2,300 RPM, depending on what they were working. So over-the-road trucks, they'd allow them, I think, to overspeed to 2,500, but that's it. And they didn't crank up there, usually 23, occasionally 24 in the dyno. Why do they do that? Just plain life. They know what the engine will take, keep it in there. Last thing I want to toss in there, because we're talking the 855, the later N14s, the 500 and 5 1/4s, They had 1,850 foot-pounds in one and 1,950 foot-pounds on the other rated. The claim was they had torque rise on those things and were over 2,000 foot-pounds of torque coming out of that engine. So one guy claimed that the 5 1/4 was putting out 1,950 foot-pounds of torque at 525 horsepower, which is unheard of. So that's at rated speed. Usually you lug them back in a gun. Peak torque was 1,400 RPM. So I think he was stretching things a little. So their peak was supposedly rated peak was 1950. They put out considerably more. And why I say they controlled the RPM, because they put them on a dyno and found out that there wasn't something holding the block, being cast steel instead of cast iron, the block would twist. And they would find that some corners of the oil pan, I don't know if it was the front or the rear, but the block would twist 3/8 of an inch to 1/2 an inch in some cases. And they went through a full life on dyno testing up and down and all around. And he says they'd go 100, 200, 300,000, 400,000. Says they go the whole distance and never have an inline problem all the way down the crank. It would literally twist around the crankshaft and get a full life out of the truck. That's how close that some of these companies have looked at their products. Anyway, hopefully that'll help some of you as you're going through studying diesels in particular, because you won't find much of this stuff in cars except fractured rods and studs and such. Why? Lightweight. That engine's turning $5,000 is what they expect it to hit every day. It's a different world. And their torque to horsepower ratio isn't so far apart. It's not like having a torque number 4 times the horsepower number. No, they're usually fairly close. So, different world. Different percentages of load, too. Diesels and heavy equipment, construction, even farm equipment are 90% to 100% load that they consider the engine to operate at. Cars, 25. Haul trucks on the highway, up to 50. Yeah, many different worlds. That's why there's different oils, different engines, and different designs. Time to go. 22 minutes and 25 seconds. Peace out. Lord bless.